This is the brief on geometric synthesis of spherical arc lengths. Okay, so what we're looking at here is how we can take some pretty abstract math, integrals, and use it to measure real actual distances in 3D space. We're going to do this specifically with spherical coordinates. It really boils down to 3 crucial steps for turning those coordinates into a distance you can actually measure. First, before you can measure anything, you've got to define the space itself. This means figuring out the foundational rules. We're talking about the metric tensor, which is kind of like the system's rule book for measurement, and the Christoffel symbols, which act as the steering instructions, telling you exactly how paths curve on a sphere. Second, once you have that rulebook, you can build your main tool, the integral formulation of distance. This is the integral that's going to let you translate a change in coordinates into an actual physical length along any path you can dream up. And finally, we put it to the test. Does all this abstract math actually work? Well, we trace a simple path, a circle on the sphere, where the radius and polar angle are held constant. And what's amazing is that the complex arc length integral, it just simplifies down perfectly to the circumference formula we all know and expect. It's the ultimate check, showing the math lines up exactly with physical reality. So these foundational calculations are what truly connect the geometry, the integral you build from it, and the real-world distances you can actually see and measure.